Want to use every minute today? Get going. Okay, you are almost there. All I want you to do is lock it in for an hour. Okay? Class like normal, lock it in for an hour, then go be dumb, regret your decision the rest of your life. Okay? Probably. Please don't stank. That's what I say to my freshman class every white day. Is anyone still going? Like, looks like we're about finishing up. Maybe figuring out the shading part. I don't want anything to be a getcha. Take real close look at the inequalities. What does each symbol mean? What direction am I going? So you should just dump that 5 in there and walked away with the box. It was 2 years ago. We had a kid. I don't remember what his name was. He'd come in here and he'd just buy a whole box. Then he'd go out to the commons and he'd sell it for twice as much. Hey, bud, I got mine. You go get yours. Anyone still rolling? Finish up the last piece there. Okay. The first one I can graph either by intercepts or slope-intercept form, whatever your jam is. I'm okay with graphing by intercepts. I see 0 in for y, x-intercept at 10/3 or 3 1/3. 0 in for x, y-intercept at -2. Grab a straight edge, connect the dots. Okay, or if you chose, you can turn that into (3/5 x minus 2). But you'd have to remember to swap the inequality's direction when you did. Okay, so I would start at 2, and then from there up 1, 2, 3 over 1, 2, 3, 4, 5. Sure enough, that's the line right there that went through that x-intercept. Or down 3 back 5. Or down 1.5 over 2.5, so I can actually make a decent line. Solid or dotted? Okay, less ink here, less ink there. Now, if I didn't have this part, if I didn't have it in slope-intercept, we know that just says y is below the line. How would I do it with standard form? How would I decide which way to shade if it was in standard form? Just figure it out. Pick a point. See if it's part of the solution set or not. Okay? Stick a 0, 0 in there. I get 0 is greater than 10. Is that true? Nah. So if 0 is not true, then nothing on that side's true. Shade down. The other one, ironically, 2 weeks ago, that would have maybe scared us. I don't know. But now that's probably actually easier for some of you than this because it's just move this way, do this slope. It's already in the format I need. I don't have to mess with it. I'm going to go right 1, up 3, vertex. From there, slope of -2, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, or mirrored across axis symmetry, down 2, left 1. Solid or dotted? That was, yeah, that was right. Womp. Womp. And it says y is less than or equal to the v. So I shade below the v, meaning inside of it. And I look for where is everyone pointing and say right about now. So, pointage. Do we have the correct line, the correct vertex, the correct slope, the correct solid or dotted, the correct shading? So the line's just a point because, y'all, we've been doing lines a long time. The absolute value, correct vertex, and correct slope are 2 different points. Did you have the whole solid dotted thing figured out? Did you have the shading thing figured out? Cool? So something out of 5. I did not receive any questions. At least I don't remember any questions. Yo. Oh, you don't actually have to do that today. If you are required to be in Spartan time, yeah. Withholding comment. Continue. Nothing? Just jump straight in, get her done? Okay, cool. So we left off with substitution, and then I tell you I hate substitution. I really do. It's a burning friggin' passion. Did you do this one? I don't remember. No. I know we did this one. Did we do that one? No? I need confirmation from the people who take really, really, really good notes, because there's the chance that you might have just spaced out when we finished it. We did not. Okay. I'm seeing multiple people now say no. All right. Got to confirm. So y'all get this idea that you isolate one of the variables and you say, if x is this crap, replace everything with this crap. And now I got a 2-variable system. The problem is there's a lot of extra writing with that one, and I think we can go faster. So I'm going to show you this 2 ways. Okay. Are y'all cool right now with, like, I got to make sure, since I found out that I do my 2's 2 different ways as I'm writing, you can all tell what's a Z and what's not. I always put my line through Z's. Okay. Like, I will literally write that on the board and not even notice I did it. So I just got to make sure Z always has a line through it for that reason. Okay. Then, option number 1, substitution. you pick one of those variables, x, y, or z, to get by as lonesome. And just like when we did substitution with two variable systems, you're like a lion stalking the herd. You want the weak and the sick. Who is easy to get by themselves? And that's usually something that's got a coefficient of 1 or -1. So what pops out to you like, I can get that one by itself real easy? X, Y, and Z all have a coefficient of 1 or -1, right? They've all got it. So I'm just going to do X because it's right there. I would rewrite equation 1 by subtracting these two over to the other side, or subtract and add, and say if X is 2y minus z minus 4. Y'all cool with that? Add the 2y, subtract the z. Okay. If I say X is this stuff, the goal of 3-variable systems is to not do a 3-variable system. Do a 2-variable, because you know how to do that. So now that I know X is this stuff, I'm going to rewrite equation 2, and I'm always going to put that 1 or 2 next to it so I know how I got here. Some of you trying to follow your work is like it's not even chicken scratch. It's like you need the friggin' Rosetta Stone to translate it. So please, at least put these next to them so I can tell what's what. Or just go copy Alexa's stuff. Okay. -4 with a thing plus y minus 2z is 1. I also have equation 3 is 2 by a thing plus 2y minus z is 10. And in there goes my x stuff. 2y minus z minus 4, 2y minus z minus 4. Simplify both. Call that -8y plus 4z plus 16 plus y minus 2z is 1. Blech. Okay, I see -8y plus y is -7y. I see 4z's minus 2z's is plus 2z. And I'll subtract that 16 over so it's in standard form. Variable, variable, constant. Do it again. 4y minus 2z minus 8 plus 2z minus z is 10. It's a lot of writing. Oh, my knees just made noises. 4y, -2z and 2z is 0. Oh, that's a y. Okay. Whew. Yeah. All right. -2z. Oh, yeah. We got to back all that up then. Get down here, Frank. Okay. 4y's and 2y's is 6y's. -2z and then is minus 3z. Add 8 to the other side, 18. Okay. Now the reason that I'm kind of doing them like this, so I can take this and just kind of... Okay, so I'll just leave it here. All right. How about this? Now I'll show what's going down. Now along the way, before I write this next system, before I just rewrite these, can I make either of them easier, simpler? I can divide this by 3. Now the reason I want to do that on the fly, if I can, is it's going to make the next stage, instead of multiply by 2 things, multiply by 1 thing. So I'm going to rewrite this. -7y plus 2z is -15. And I show the arrow saying I am rewriting this, so along the way, how about I say divide by 3? 2y minus z is 6. But do you see how you can still follow the arrows? You see what's happening, right? I did this to equation 1. Equation 2, I replaced and I rewrote. Equation 3, I replaced and I rewrote. But when I rewrote, I made sure to divide it by 3 to make things easier. And now I have a system with only 2 variables. Now I can solve this one. Yep. I'm going to take this fella right here times 2. I am going to rewrite both because, again, that whole transference thing, I don't want to accidentally use the wrong numbers by going vertically across the problem. This is me personally, doesn't have to be you. I'm going to take this guy times 2. 4y minus 2z is 12. And I get negative 3y, cancel town, is negative 3. Y is just 1. So if I know y is 1, I can come back to either one of those equations. Say 2 by thing minus z is 6. Like that. And I have 2 minus z is 6. Subtract 6, add z, or subtract 2, divide by negative 1. Either way, z is negative 4. The goal of a 3-variable system is I don't want 3 variables, I want 2. Eliminate a variable 2 ways. Cool, I have a 2-variable system, I'll solve it like normal, like I'm back in algebra half. But look at how much work I had to do to get rid of it. Now that I have 2 variables, I can solve it. I know what y and z are. So, finish it off. If you know y and z, go find your x. And say x is 2 of those minus 1 of those minus 4. I know that y is 1. I know that z is negative 4. I smash it all together and say 2 plus 4 is 6. 6 minus 4 is 2. Now at the very end of the problem, don't just quit there. I found this, I found this, I found this. So I'm going to write my 3-dimensional coordinate 2, 1, negative 4. Okay, U. It is. Okay. Save. Screenshot desktop. There it is. Okay. Now, I want you to look at the different stages or places of this. Step 1 was to eliminate a variable 2 different ways. Getting a two-variable system. It creates a two-variable system to solve. Once I'm done with it, I go back to the beginning and I solve for whatever I eliminated. Now, I said I'm not a fan of substitution. I'm not a fan of it because of the extra writing right here. I'm going to try again. I'm going to show you elimination. Now I'm going to put them side by side and let you decide what you like. Okay. You don't have to write this part. I'm just going to show you both. Okay. Fine, you. There we go. So this has always been my preferred method. You have to eliminate a variable two different ways. Think about elimination. I always take this equation plus this equation, and one of them goes bye-bye. What up there, you know what? I'll even just use x's again, because that's what I used before. What's one way that I could combine those equations to knock out x? Right? Just take this times 4. 4x's minus 4x's. Poof, gone. Right? Nice and easy. So I write that. I'll say 4 times equation 1. It's 4x minus 8y plus 4z is negative 16. I'll use equation 2. Negative 4x plus y minus 2z is 1. And when I combine those, x's go bye-bye, negative 7y plus 2z is negative 15. Cool, do it again. Do it a different way. I could take this times a negative 2 to knock him out. I could take this times 2 to knock him out. You just have to do it two ways. Which one? This guy by negative 2? Or sorry, this guy by negative 2 with this guy. Or this guy by 2 with that guy. They're both going to go away. A single person is saying this one. Okay. So I'll use negative 2 with equation 1 times a negative 2. Negative 2x times a negative 2 plus 4y times a negative 2 minus 2z times a negative 2, 8, with equation 3. 2x plus 2y minus z is 10. X's cancel. 6y minus 3z is 18. Same ones we got last time, right? And I can say you and you come down here, but while I'm on the way, divide you by 3. Negative 7y plus 2z is negative 15. 2y minus z is 6. I think most of us preferred take this times 2. get negative 3y is negative 3, y is 1. Plug it back in. So I get 2 minus z is 6. Z is negative 4 again. All the way back to the beginning to solve for x. Take one of your originals. X minus 2 of those plus 1 of those is negative 4. Plug in those fellers. Where'd they go? All right. 1, negative 4. X minus 2 minus 4 is negative 4. X minus 6 is negative 4. X is 2. 2, 1, negative 4. I think it's about the same amount of writing, honestly.
Yeah, but I think...
And this is why I said, I want you to do both. They are both correct. Okay. Did you really just your mom? Okay. And then save. Okay. You go away. There you go, side by side. But I want you to pay attention to like the how of it. Eliminate a variable 2 ways. Get the 2 variable system. Solve for whatever was missing. Eliminate a variable 2 ways. Get a 2 variable system. Solve for what was missing.
I guess one part's longer than
Right?
Yeah, but also the white wasn't in the corner, so
Yeah.
as much space. But I mean, still.
So I prefer this way because the distribution and then combining just kind of bugs me right there. But that's a personal preference. You do what you want, right? You do the way that works for you. Now, you got to know how to do both. Like that's literally the standard. Can solve multivariable systems in multiple methods. But you get your choice. They're both going to work. So, let's roll one more time. So we've done two with substitution. I'll do one with elimination here for you. Now this problem, I call it magical Christmas land. Because sometimes doing the work, something just goes away and it makes the system a lot easier. Like altogether, gone, 6, 18, 4, that's 6. 6, smack those together, that's 2. Right. 2, 3, 18, 5, negative 3, negative 1. 2, -1. 3 is -1. -12? 2, -1, -12? Oh, we'll check. What looks easy to get rid of?
X. Or anything.
All of them, right? Because I see a 1 or a -1 anywhere in there. Personally, I'm aiming at Z's. Because I see 1, -1, -1. I literally don't even have to multiply. There are 2 ways to eliminate right here. So that's my personal choice. Doesn't have to be yours. I could take y with y, take this times 3 and get rid of him. Could take that times -2 and -4 respectively. Take that times a -2 to get rid of that one. Like, it turns out there's like 24 ways to start the problem. And they're all right, as long as you're following math law. So, I'm going to start by labeling. Always label. I'm going to say equation 1 plus equation 2. 2x plus minus y plus z is 4. X plus 3y minus z is 11. I'm also going to have equations 1 and 3. 2x minus y plus z is 4. 4x plus y minus z is 14. Okay, goes bye-bye. 3x plus 2y is 15. But goes bye-bye, goes bye-bye. That's what's magical Christmas land. That doesn't always happen. It does not always happen. Now, you're still going to have a 2-variable system. It's just a ridiculously easy 2-variable system because you already know one of the variables. It is still a 2-variable system, though. If I do this, and then just along the way, yeah, divide by 6. So 3x plus 2y is 15, and x is just straight up 6. So it cuts down the time on our 2-variable. Did I say 6? God, I wrote 6, and then I put a 3. I should probably start writing those down, or else I'm going to forget. Is my marker still over here? Negatory. Harrison! Marker! There's like a gap in the bridge and a bunch of crap in front of it. How did you think that was going to work? All right, let's try that again. All right. Let's try this again. X is 3. So now I got 3 by a thing plus 2y is 15. In goes 3 and get 9 plus 2y is 15. 2y is 6. Y is 3. Now what? You got an x. You know y. Move on and find a z. Right? Going to go all the way to here, and I'm going to use equation. I'll use 1 since it's positive. Say 2 of these minus 1 of those plus a z is 4. X is a 3. Y is a 3. Get 6 minus 3 is 3. 3 plus z is 4. Z is 1. Write your final coordinate. 3, 3, 1. But look again at what we did. Eliminate a variable 2 different ways. Whether you do that by substitution or elimination doesn't matter. That is personal preference. Solve a 2-variable system. The way that I like this is because I can just kind of do a cycle on my paper and I can keep my problems in a box. Okay. Now that's me personally. That was a really good circle.
It was actually really good. Do you have like straight edge for circle too? Straight circle? What?
Do I have straight circle? No, I do not have straight circle. Okay. That was me all day yesterday. I couldn't talk. All right. I would like you to try it. Whatever way you want. Substitution or elimination, do it the way you want. I see 2, 4, -4, 1, 1, 2, -2, 3, 5, -3, 3, 5.
What'd you say? What?
1, 2, -2. 1, 2, -2.
Yes, sir.
X is -2z minus 2. X is 1.
What'd you get next? One's making. They're both positive. What?
0. Is there really a 0 in there? One, -1.
I saw that as a tool. Yes. I got to. I'm sure it was divide this all by 2. I'm sure it's positive 3. That's what I did unless I did something. Yeah, you probably did. I just used to think. Yeah, usually that always by 2.
You've done all this mess before, right? Do you do it with matrices?
Oh, yeah, I did. Yes, I did.
Don't remember? Okay, I was just wondering, like, if you know it that way, just do it that way. Okay. All right.
Oh, that's
Divide by that.
Out of curiosity, who eliminated x's first? Y's? I'm seeing bobbleheads. Z's? One or two? So I'll go with y's just so I'm at the majority. If I take equation 1 and equation 2, y's will just straight up cancel, which is probably a path of least resistance. Getting 2x plus 4z is negative 4. I'll take equations 2 and 3. X plus y plus 3z is negative 3. 2x minus y, 2z is 0. Getting 3x plus 5z is negative 3. Cool so far? Add this, y's go bye-bye. You might have to multiply along the way to make that work. Once I'm there, it should actually just kind of take care of itself. It's just two variable systems. It's getting there that's the trick. Now that I'm here, y'all cool if I along the way divide this by 2? X plus 2z is negative 2. 3x plus 5z is negative 3. Now, I can take this feller times a negative 3. Getting a negative z is 3, so z is negative 3. If z is a negative 3, x plus 2 of those I get negative 6, add it to the other side. X is 4. And if I know x and z, I can head back and find y in any one of the originals. I'm going to use equation 2. An x plus a y plus 3 of those is negative 3. We just found out that x was 4. We found out that z was negative 3. So I get 4 minus 9 is minus 5. Add. Eliminate a variable 2 ways. Solve the 2 variable system. Go back and solve for what you eliminated. Okay. Who do what?
So when I plug them back in the first equation for x and z, 4 is x.
4 minus 3 is 1. If I subtract 1, that's now a negative 2. Okay, just missed a sign. Okay. This is also where writing it out, showing your work, is going to be huge. If you aren't showing your work, or if you aren't writing the steps, if you don't have this Madden football play from hell over here with the arrows that has the I divided by 2, you know, we're going to do a double reverse triple options, like whatever. At that point, you're just playing catch in the backfield, okay? If you're not going to do that, if you're not going to tell me what you're doing, show it. It's just going to be a pile of letters and numbers. You're not going to know what you did. I'm not going to know what you did. But if you show the steps, here, let's get rid of, oh, put that down. If you get rid of all of this extra color here, okay, eliminate a variable 2 ways. Get two variable equations. Solve that 2 variable system like you're back in Algebra half. Then come back here. What it boils down to is eliminate a variable 2 ways. I should have said eliminate the same variable 2 ways. Then you get a 2 variable system. Then you go back and solve for what you eliminated. That's it. That is 3 variable systems. The catch is right here. You can choose elimination or substitution depending on your personal preference. Now, I suppose technically you can do it here too, if you prefer doing 2 variable systems by substitution. You get the choice in both of those, and you can mix and match. You can eliminate first and then do your 2 variable by substitution. You could do the first step by substitution, then do the 2 variable by elimination. Go for it, I don't care. I know my preference. That doesn't mean you have to. So, wait, by elimination, that's the same thing but more practice, right? More practice, more practice. We're not going to get to the words, not even close. Okay, we'll try one more. I don't care what method you use. I just want you to try again. Just try again.
Okay. So we can. Oh no.
You know what? Just to make sure that everyone's kind of doing the same thing, what should we eliminate first or get by itself?
Why?
Why?
Eliminate X though.
What if we do Y? It would be
Eliminate X.
X would
That way
be
you don't
easier.
have to multiply.
It'd probably be better to do X.
But you got to do it 2 ways, remember?
Yeah.
Yeah, it'd definitely be better to do X.
The second way works.
Neither of them really
It's the same
match.
thing either way.
I'd say X.
All right. Go your different paths. We feel strongly about either one. Go do you.
Is there a special one? Is there like a?
No. I was hoping that we could all do the same thing, but meh, whatever. So that's 6, 20, cancel 2, 1, 3, 10, and 1, 1, 4, 1, 3, 10, 1, 1, 4, 2. C is 3. 3, 1. All right, let's check it. 1, 1, 2, 3, 2, 1, 3, 7, -1, -2, 1, 10. 1, -4, 3. Even getting 5 hours of sleep a night for a week, we still got our mojo. That's the end of the rainbow. Once you got the end of the rainbow, go ahead and pack it up. Okay? Here's the deal. Early release killed us. We missed a half-hour class. Normally, we would have been able to finish. I do not feel comfortable assigning this without finishing. No homework. Enjoy your weekend.
Thank you.
Y'all, don't do anything too stupid.
Probably not actually.